Hello everybody and welcome to our first lesson in Algebra 2 Trig. Unit 1 will be about characteristics of functions, and in today's lesson we'll talk about analyzing a graph to identify the domain and range of a function, describing restricted, discontinuous domains and ranges, and describing the end behavior of a function. So let's get started. At first, I want us to spend some time remembering two concepts that you have known since Algebra 1, the domain and the range. Domain is the set of all possible x values in a function. In other words, we look along the x-axis from the left to the right for all the x values that are represented on the graph we can see in our coordinate plane. The range of a function is the set of all possible y values. This means we are looking along our y-axis, our vertical axis, starting from the bottom, going all the way to the top, and looking for all the y values which are part of our graph. End behavior tells us what the ends of the graph do, and as x goes to negative infinity, f of x goes to wherever we find out analyzing that function, and as x goes to positive infinity, we also need to figure out where f of x, in other words the y values, go for that part of our graph. There are two ways to write down and describe the domain and the range of a function. One is called set notation. Set notation uses braces, and then for the domain, the x, such that, and after that comes the condition that all the x values have to fulfill to be part of the domain. For the range, it would look like this, open braces, and y, such that, and after comes the condition that all the y values have to fulfill. Please realize that for set notation we have to be clear and have to use x when we talk about domains and y when we talk about ranges. Interval notation looks a little different. Here we use different sets of parentheses. We use actually brackets every time that our graph shows a closed circle. And we use regular parentheses every time the graph shows an open circle or arrows. Let's look at a few examples. And we're going to assume for these examples that all endpoints are indeed integer coordinates. Let's look at the domain of our first example. The smallest value that's part of our graph seems to be starting here and then going over to the right. This is how far our graph goes. For our domain, that means that in set notation we write x such that -3 is less than or equal to Remember, this is a closed circle, so negative 3 is part of the curve, less than or equal to x, which is less than or equal to positive 4. Again, less than or equal to, because the circle is a closed circle. In interval notation, we would write it like this. Since we do have a closed circle, we're going to use a bracket, negative 3, comma, positive 4, closed bracket. Let's look at our range. The lowest y value that's part of the curve is down here, and it goes all the way up here. In other words, in set notation, the range is y such that negative 1 is less than or equal to, closed circle, y, which is less than or equal to positive 3. In interval notation, we write open bracket negative 1, comma 3, close bracket, both times with brackets because the circles are closed. Let's look at our next example. The domain starts towards the left, here where we have the closed circle, and goes all the way to the right where we have the open circle. In set notation, we write therefore open braces x such that negative 4 is less than or equal to x, which is less than, no equal to, this is an open circle, less than positive 4. Close our braces. And therefore in interval notation we will write open brackets negative 4, comma, positive 4, parentheses. The 4 is not part of our domain. Let's have a look at our range. Our closed circle is tempting, but that is actually not the lowest point of this curve. The lowest point is over here, where this point goes further down than the closed circle. And the highest point is up here, and also here, the point that actually matters to us is this point, which is higher than the open circle, because the number at the open circle is not part of the range anyway. In set notation, therefore, we will write open braces y such that negative 3 is less than or equal to, this point clearly reaches negative 3, y, which is less than or equal to, at the point where I made the arrow, the point touches positive 3, and this is the uppermost value of the range. Close your braces and you are good. In interval notation, we will write open brackets negative 3, comma, positive 3, close brackets. Let's look at the next example, which is a little different, as you will already have seen most likely. Looking and thinking about our domain, we see an arrow here, and this arrow indicates to us that while the curve goes up, it also keeps going further and further to the left, so there is no lowest value. And the same actually happens on the right with this arrow. There is no greatest value that's part of this curve. The curve keeps going in both directions, on and on and on. So therefore, our domain is x such that, and now we're talking about numbers that go all the way to from negative infinity to positive infinity. But to make things easier, all you need to write here is x is an element of the real numbers. All real numbers are part of this domain. In interval notation, you will use the infinity symbol, and since we can never reach infinity, we are using parentheses. So parentheses open from negative infinity to positive infinity, closing parentheses. Our range is a little different. If we look at our range, then we see that our lowest value is up here. But then again, the arrows go up. Actually, both arrows go up all the way. And so there's no greatest value. This means that for the range, we will write y such that all y's have to be -3 or greater. In other words, y is greater than or equal to -3. In interval notation, we are going to write open brackets -3, comma, infinity, closing parentheses. Whenever we have infinity, we always have parentheses. We never use brackets because infinity is something that we can never reach, so it's never actually part of our range or our domain. This is the first part of this lesson, and we're going to continue with the second part on the second video.